If you talk to traditional IT security team, they will give you a very simple rule for cloud architecture. Put everything inside a virtual private network. Do not expose anything to the public internet. And for pure Azure-to-Azure architecture, they are 100% right. But we are Business Central developers. And when it comes to Business Central SaaS, that traditional security advice hits a massive brick wall. Welcome to week 11 of the 90-day Azure Roadmap. Today we're going to have a very honest conversation about network security, Business Central constraints, and how you actually lock down your integrations when the ideal solution isn't possible. Let's talk about the reality of BC networking. Let's define the ideal scenario first. In a perfect world, you would create an Azure virtual network. You would put your Azure function inside it. You would put your Business Central inside it. They would talk to each other over private internal IP addresses. Nobody on the public internet could even see your integration. Here's the BC reality. You cannot put Business Central SaaS tenant inside your Azure virtual network. Business Central runs in Microsoft's multi-tenant infrastructure. You do not control the network layer. When Business Central makes an outbound HTTP call to your Azure function, that travels over the public internet. I see developers and IT admins waste weeks trying to force BC into a private endpoint or a VNET integration. Stop! It doesn't work that way. So if our Azure function has to be accessible from the internet so BC can reach it, how do we stop hackers from reaching it too? The first layer of defense is IP restriction. We only want to allow traffic from Business Central, but Microsoft's IP address for Business Central change. You can't just whitelist a static IP. This is where service tags comes in. A service tag is simply a group of IP addresses prefix managed by Microsoft. Microsoft updates the list automatically. Let's apply one of the to an Azure function we built. So let's go to our Azure function, go to settings, we go to networking, and we click on enable with no access restriction. Enable from a selected, we press add to add a rule, and instead of IP, we're going to use service tags. And here we should find one that's called Business Central. Give it a name. Let's just call it BC. A priority. And let's add that rule. So as you can see now, it should deny anything other than our Business Central. And let's press save. Now here is a massive limitation you need to understand. I cannot stress this enough. The service tag allows traffic from the Business Central service. It does not mean only my specific tenant. Any Business Central tenant in the world running on a Microsoft infrastructure now has networked access to your Azure function. If someone knows your function URL, they can spin up a free BC trial tenant, write some AL code, and hit your endpoint. Service tags are not a magic bullet. They are just one layer. Because of that limitation, we cannot rely on networking alone. We have to use a concept called defense in depth. If one layer fails or has a broad limitation like a BC service tag, the next layer catches the bad actor. Let's look at our architecture layers. Networking layer, service tags, fills out 99.9% of the internet. Only Microsoft BC IP addresses can connect. Gateway layer, API management from week 8. We put API management in front of our function. It enforces rate limits. If a rogue BC tenant tries a denial of service attack, API management shuts it down. Authentication layer. The caller must provide a valid credential even if they are calling from a BC tenant. If they don't have the API key we stored in our key vault, they get a 401 unauthorized. And number 4, the application layer. Your code validates the incoming payload to ensure it makes logical business sense. This is how you build a secure public endpoint for Business Central. You assume the network is hostile, and you verify every single request. Now I said BC has to travel over the public internet to hit your entry point, API management or your function. But what about the rest of the architecture? What about your Azure function talking to your Azure Key Vault or your function talking to Azure Service Bus? Those are pure Azure to Azure communications. Those should be entirely private. For those, we use private endpoints. A private endpoint puts a virtual network interface directly into your VNet. You create a VNet, you connect your Azure function to the VNet using VNet integration, you create a private endpoint for your Key Vault and your Service Bus inside the same VNet. You disable public network access on the Key Vault and your Service Bus entirely. Now your BC tenant hits your function, secured by service tags and auth. Your function does it processing and talks to the vault and queue over a completely invisible private Microsoft backbone network. That is the practical architecture. Public entry point, strict private backend. Understanding the constraints of your platform is what separates a developer from an architect. You can't put BC in a VNet, but you can build a secure defense in-depth architecture anyway. Your homework for week 11. Go to your Azure Function app or API management instance. Configure the access restriction to use the service tag Dynamics 365 Business Central. Open Postman on your local computer and try to hit the endpoint. Verify that it is blocked. Trigger the call from Business Central. Verify that it succeeds. Document the security layer in your architecture, service tags, API management, auth. Next week, we are at the finish line, week 12. Next week is our capstone. We're going to put all 11 weeks together into one final production-ready architecture. We'll draw the diagram, review the cost optimization, and look at deployment strategies. See you in week 12 for the final.